I'm Professor Marcia Lin from the University of California, Berkeley. Our partnership of teachers, students, technology experts, assessment experts, learning scientists, and curriculum designers has exciting news about graphing research on inquiry with data in science, the GRIDS project. Teachers want their students to integrate the insights possible from graphs to understand complex topics. Graphs help students integrate ideas by taking advantage of the human capacity to identify patterns, uncertainty, and critical events in large amounts of data. Yet, students and many adults struggle to integrate the linear graphs they use in mathematics with the nonlinear, noisy graphs common in science. The GRIDS partnership is creating and testing curriculum materials that help teachers guide their students to integrate their ideas by linking graphs with science concepts.
What is the best cup material to use to maintain the temperature of a beverage? Can you use the same material to keep both a hot drink hot and a cold drink cold? Students make predictions and then test their initial ideas to investigate these questions in the Thermodynamics Challenge Unit. An interactive model with experimentation grid lets students run tests to explore two variables, cup material and beverage temperature. The dynamic representation on the lower left helps students to observe the transfer of heat energy. The graph on the lower right shows the resulting heating or cooling curve for the experimental test. Each test is logged in the experimentation grid. The grid can then be used to select tests to compare for more detailed analysis. The Thermo Challenge Unit and model helps students integrate their knowledge of thermodynamics with their interpretation of graphs to develop an explanation supported by evidence and data.
In the photosynthesis unit, students learn from a model that shows how organelles work together to make, use, and store glucose, which keeps the plant alive. Using this model, students predict what the running totals would be for the amount of glucose that has been made and used so far, and the amount in storage. Students construct graphs to show these predictions, and they say what their graphs are meant to show. This helps us see whether students have integrated ideas about the science, but can't express them with a graph. While students draw their predictions, automated guidance helps students think about what their graphs mean. These students know the plant only makes glucose in the light, so the line is only drawn in the light. Automated guidance says to keep drawing the line through day 15. Then the guidance says, according to your graph, the total glucose the plant has made in its whole life is lower at day 16 than day 8. Think about a sports team. Can their total score be lower at the end of the game than it was at halftime? The students correct their graph and end with an accurate prediction.